So when we list the perfect squares, we're just generating these by ourselves, thinking like 1 times 1, 2 times 2, 3 times 3, etc. It's pretty easy up to 100, and then when you get like these higher numbers, it's a little bit harder, but those should be numbers that you know. Is 9 a perfect square? Yes, because 3 times 3 is 9. But the other two are not, right? But 4 is, because yes, 2 times 2 is 4. You want to be careful that you understand the square root of 4 is 2 versus 4 squared is 4 times 4 is 16. Square root of 16 is 4, 11 times 11, 121. And then if I say the exact square root of 8, right, that's going to be square root 4, square root 2, or 2 root 2. That's the difference between exact and approximate. People get real confused on this, like what it's in between, right? So the square root of 23 is between 4 and 5 because 23 is between 16 and 25. The square root of 67 is between 8 and 9, and the square root of 41 is between 7 and 8. Here, if you're simplifying the square root of 20, you're separating it into one you can do and one you can't do. So, for example, the square root of 9 is 3, and you're left with the square root of 5. You want to make sure you're picking the biggest perfect square. So there it's square root of 16. Square root of 100, square root of 6 is 10 root 6. If you have a number in front, it just goes along for the ride. So 7 root 9 root 2 is 7 times 3 root 2, or 21 root 2. It's 10 root 4 root 3. The square root of 4 is 2. 10 times 2 is 20. And so on. Here we have square root of 75 is square root of 25, which is 5, so 35 root 3. Here you're going to multiply it together to square root of 50 and then take it apart, 5 root 2. Square root 2 square root 12 is multiplying to square root of 24, and then I take it apart, 2 root 6. Here I'm going to multiply my outside two numbers together to 36, and then the inside numbers to 10, and then that multiplies to 360. Similarly here, except square root of 20, then I would break down 15 times 2 root 5, or 30 root 5. 6 root 7 quantity squared, you want to write it twice, so it's 36 root 49, or 36 times 7, which I believe is 252. Here, when you're doing these on a calculator, you want to make sure that you are rounding correctly. So if I take 11 and then take the square root of it, I want to make sure that I round it correctly to 3.32. And you see that squiggly equal there to show that. Here this 5.099 rounds to 5.10 or 5.1. And then 6 root 2 is 8.49. And here 4/5, if I take the square root of that, then I'm going to get 6.16. Pythagorean Theorem course, a squared plus b squared equals c squared, only used for right triangles. Here we're looking and saying, does 4 squared plus 7 squared equals 9 squared? And you could do that on a calculator and see that it's not going to work. You want to make sure that your c is always your biggest number, and then that one is going to work. And you do have to show the work here. I'm just writing the equation, and I just know kind of which ones work, but you know, it's an a squared plus b squared equals c squared kind of thing, and then it's either a yes or a no. You want to make sure that you set your equations up correctly where they're always equal to the c squared. So I like to darken in that side that's across from the right angle. Maybe even write all my equations first, right? Just to say, like, I've got them set up correctly. So we're just going to now do the math, really, right? 9 plus 36 equals x squared. So now you have to understand the difference between exact and approximate. Exact is when we say square root 9, square root 5, or 3 root 5. That's the exact answer. The approximate answer is when we type in to our calculator square root of 45. So that's the difference. So hang on a second. I'm looking it up on my calculator. And then that's 6.71. Or here, 9 plus x squared, 3 root 2 squared, 3 root 2 times 3 root 2 is 9 root 4, which is 9 times 2, which is 18. So x squared equals 9. When we square root 9, that's perfect square, so it's only 3. And then here, when we subtract 1 from both sides, we get 3. So the exact answer is square root of 3. And then the approximate answer, if I do that on the calculator, 1.73. Oops, 1.73. Our little story problem, we always use the same picture. That's always the ladder. It's reaching up the wall 16 feet, so it's x squared plus 16 squared equals 20 squared. 16 squared, of course, is 256, and then 20 squared is 400. So on a calculator, I'm going to subtract 400 minus 256 is equal to 144. And then when I square root that, I get x equals 12, and I'm going to add the feet. The length of the diagonal of the square, that's the hypotenuse, so 8 squared plus 8 squared equals x squared. So when I add 64 and 64 is 128, and the square root of 128 is root 64 root 2, or 8 root 2. So really that's one of our special triangles. So here's our special right triangle rules, x, x, x root 2. So the legs are x, and then this is x root 2 times the hypotenuse. So these are isosceles right triangles because we have two sides the same. Versus 30, 60, 90 is x, 2x, x root 3. And so that side opposite the 60 is root 3 times the shortest side. Hypotenuse is double the shortest side. Longest is across from the 90. Shortest is across from the 60. And this is a scalene triangle with all sides different. So here, 5, 5, 5 root 2. I'd like to write it on the picture as well as on the answer blank. 3, 3, 3 root 2. Like that. Root 11, root 11, root 11, root 2, and root 11, root 2 is root 22. Root 7, root 7, root 7, root 2 is root 14. Here, if the hypotenuse is the 16 root 2, it would both be 16. Here it would both be 11. These tend to go really quick for people, both be 2. And then here you got to divide by root 2, so that one's a little bit harder. It's root 5, because root 5 root 2 is root 10. Here in the bottom with the 30, 60, 90, if the side opposite the hypotenuse is 6, so then the x is side opposite the 30 is half of that, and then 3 root 3. Similarly, we have 4 and 4 root 3. Or opposite x would be 8, and then 8 root 3. Opposite the 30 here would be half of 12 is 6, and then 6 root 3. Now it's switching to opposite the 30, so now I double it for the hypotenuse and multiply by square root of 3 for the side opposite the 60. Double it for the hypotenuse, multiply by the square root of 3. Double it for the hypotenuse here, which is the y, and then the x is the 10 root 3. Double it, ooh, that one's a little tricky. If I double it for the hypotenuse, it's actually 6 root 3. And then this side is 3 root 3, which is 3 times 3 or 9. So these two are a little bit harder than what would be on the quiz. Last row here, now the side opposite the 60 is 4 root 3. That makes the side opposite the 34 and the hypotenuse 8. Or here, the side opposite the 38, hypotenuse 16. Side opposite the 30 here would be 18. 18 times 2 is 36. And then here, that's 20, so this would be 10 and 10 root 3. That's it.